The next type of factoring, which you may not have seen yet, is factoring by grouping. So polynomials that contain 4 terms can be factored in pairs. So if we take a look at this example down here, this is a polynomial with 4 terms, and what you want to do is kind of break it up into 2 different binomials. So if we're looking at our first binomial here, 2x cubed minus 3x squared, we want to think of a GCF. So in this case, our GCF would be x squared. So if we factor out an x squared, we get 2x minus 3. So for the second binomial, we want to again look for a GCF. So our GCF is a 9, but we want to write our sign as well. It's a positive 9. So when we factor out a 9, we get 2x minus 3. The next step is to once again take out a GCF. In this case, our GCF is 2x minus 3. So our GCF is one binomial, and our second binomial is whatever's left over. That's x squared and a positive 9. Now some of you might want to factor this by difference of 2 squares, but remember you can't factor this any further because this would have to be a subtraction sign. X squared plus 9 you can't factor any further, so this is actually our final answer. So our final answer is 2x minus 3, x squared plus 9.
Okay, so let's look at another example of factor by grouping. Again, we have a 4-term polynomial, so we're going to split it in half and take a look at 2 binomials. Our first binomial, 8x cubed plus 6x squared, has a GCF of 2x squared. So if we factor that out, we're left with a binomial of 4x plus 3. If we take a look at our second binomial, 4x plus 3, the only common term they have is a positive 1. So if we factor out a positive 1, we're left with 4x plus 3. And you'll notice, again, we have a common binomial term. So our second step is to now factor out our common binomial of 4x plus 3. And what we're left with goes in our second binomial, 2x squared plus 1. Okay, so we're going to take a look at our final factoring method, which is factor by grouping with trinomials. So you've factored trinomials before using tram, but this was when our a coefficient was equal to 1. So we're going to take a look at when a is not equal to 1, and we're going to use most of the steps from factor by grouping. So if you notice, we have 8c squared minus 13c plus 5. Our first step is going to be determining the product of a and c, which would be 8 times 5. So if we do 8 times 5, we get 40. We are going to now determine what factors of 40 will also add to our b term, which is negative 13. So we're multiplying to 40, and we're adding to negative 13. So we're using the factors 8 and 5. Since 40 is positive and 13 is negative, they're going to be a negative 8 and a negative 5. So the next step, we're calling it ungrouping. We're going to ungroup this middle term of negative 13c into negative 8c minus 5c plus 5. So all we did was break apart our middle term, and if you notice, we now have a 4-term polynomial. Now we're going to follow the steps of factor by grouping. So we're going to split apart the polynomial into 2 binomials and factor out a GCF. So we have a GCF of 8c, which leaves us with c minus 1, and we have a GCF of minus 5, which also leaves us with a factor of c minus 1. Our common binomial is c minus 1, and we're left with a binomial of 8c minus 5. Now some of you might be wondering if where we put the negative 8c and the negative 5c matters, and we're going to show you that it does not.
Okay, so now if we do the reverse way and say we did 8c squared minus 5c minus 8c plus 5. Okay, it's not going to matter because in our first binomial here we could factor out a c, and we get 8c minus 5. And now in our second binomial here, well, we needed to match this binomial, so we're going to need to pull out a negative 1, factor out a negative 1. That gives us 8c minus 5 as well. So now that they match, that is our common factor. So 8c minus 5 goes in one parentheses, and what's left over, c minus 1, goes in the other parentheses. We get the same answer, we just did it a little different.
In our last example, here again we have a trinomial that we want to factor where a does not equal 1. So we're going to use factor by grouping. So the first thing we want to do when we do factor by grouping is multiply the first term by the last term. So 4 times negative 5 is negative 20. Now I want to think what multiplies to negative 20 but adds to negative 1, adds to that middle term. Well, negative 5 and a positive 4 is what multiplies to negative 20 but adds to a negative 1. So I want to rewrite this as 4x squared minus 5x plus 4x minus 5. And just like we saw in the last example, it doesn't matter if you write minus 5x first or plus 4x first. So I want to separate this down the middle into two binomials, and I want to look for a GCF in the first part. So my GCF of 4x squared minus 5x is an x. So I take out an x, and I'm left with 4x minus 5. Then in my second half, my GCF is really only a 1. So I'm going to write plus 1, and I'm left with 4x minus 5. And every time we do factor by grouping, you should always have that common factor. And in this case, it's 4x minus 5. So our final answer is 4x minus 5 times x plus 1. So tomorrow in class, we will be working more with factoring by grouping. So be sure to bring any questions that you have.